Hey, this is the video for FLOW.2. So go ahead and set up a new entry in your Cornell notes. Remember to start a new page for this video. Also check out the essential vocabulary. Today we'll be discussing energy and biomass pyramid, 10% rule, limiting factor, carrying capacity, and biomagnification. So an energy pyramid is, simply put, it is a representation of the energy flow in an ecosystem from a simple food chain. And this food chain contains producers always on the bottom, the autotrophs, and then primary, secondary, tertiary, and if you have a quaternary consumer. The ones you will find in living environment are going to be very simple, like this one. Now, a biomass pyramid is slightly different. This shows the representation of available energy at each trophic level. And in most ecosystems, you'll have a lot of producers, and then you'll have a lot less as you go up each trophic level. Now, why is that? That's because of something called the 10% rule. And the 10% rule states that only 10% of the energy is passed between the trophic levels. The energy is lost as heat through metabolic processes, like in other words, respiration. So an energy pyramid is just a graphical way of showing this food chain, but a biomass pyramid is a more accurate depiction because you'll show that you have 100% of all of the energy is available on the bottom, and then you have 10% in the primary consumer, 1% in the secondary consumer, and 0.1% in the tertiary consumer. The reason we don't go up to like 5th or 6th levels of consumers is because there's just not enough energy. But that's something that doesn't come up in this class. You'll have to take AP Environmental in order to learn more about that. Now, the carrying capacity is something that you may have heard before, but I'm going to use an example of deer populations over time. Deer, remember, are herbivores, so they're going to eat plants that are found in a forest or nearby a forest in a field. And over time, what happens is the deer population increases, and then it starts increasing exponentially. That means really, really rapidly, where their population is doubling on a semi-regular basis. And then all of a sudden, it might drop. And that's because they've eaten a lot of the plants, a lot of the deer start dying. Once they start dying, the plants grow back, and then the population kind of does this little shuffle back and forth. Well, this entire graph, you'll see a graph that looks very much like this. It has an overshoot, a die-off, and an overshoot and a die-off, and then it kind of levels out. And that place where it levels out is called the carrying capacity. And that is the maximum population that an ecosystem can support. The reason they can only support so many individuals is because of limiting factors. And these limiting factors are any ecosystem resources that are preventing a population from growing too large. So any resource that is necessary for an organism to survive, like food, shelter, water, oxygen, pH levels. There's many different types of limiting factors. You'll at most be asked to list maybe 2 of them. So finally, the concept of biomagnification states that organisms at a higher trophic level will likely contain more environmental toxins. So what does this look like? If each one of the producers, for example, in this example, has 2 toxins, when the primary consumer consumes them, it's not just going to eat one producer, it's going to eat multiple producers. So they're going to accumulate or magnify the number of toxins. So this mosquito larva is going to have, 6 toxins, for example. And then when you go up to the bluegill, they're going to accumulate more toxins because they're eating multiple primary consumers. By the time you get up to the cormorant, it will have accumulated so many toxins. So biomagnification, again, just means higher trophic levels, more toxins. So I hope that this video was informative. There was a lot of information that was provided for you. Please respond to this check for understanding. Thank you for your attention. I will see you soon.